Well, I decided just still to document this particular thing. I'm working on a power supply for a friend of mine, which doesn't seem to work properly. It drops the voltage quite badly when the load is connected. And while I'm just fiddling around, and I thought the driver transistors may have gone, I got a new set of 2N3055, so just testing around, and you found interesting bars have been crossed. Somebody must have had a crack at this. Let's have a look at here. I've tested these, they seem to be okay. Blue is supposed to be going to the emitter, but the way this is connected, it seems to be on the base. Yellow is the base drive, it sits on the emitter, and then on the other set of transistors here, they wired up correctly. So yellow is on the base and blue is on the emitter. So it's not that clear here, but somehow these two transistors were wired up the wrong way, and then I found that this driver transistor had blown. This is the schematic. It got 4 in parallel. Basically this one got 5 in parallel. It's a Chinese made power supply, so I got my doubts a little bit sometimes. Okay, I've taken the other heatsink out. The interesting thing is the ones which were wired up wrong, the base and the emitter were reversed on the transistors. They seem to be fine. So these two power transistors had blown as well, so I'm going to replace those so they have no readings. I'll usually mark them off. Here we have the general layout of the 2N3055. So to test these transistors, I've got a good 2N3055 here. The yellow wire is connected to the base, the blue wire is connected to the collector, and I got a reading from about 0.609 volts, which is fine. Then I usually I got one camera in one hand. Transfer this wire up to the emitter, from the base to the emitter, at 0.612 volts. Now connect these to a faulty transistor which came out of the power supply, so I'll swap this over. I do the base emitter, it might be a bit messy or not. And the reading is here open circuits. And I do go from the base to the collector. I get a reading of 0.032, so that's stoofed. As soon as I have a faulty component, it's good practice to just put an X or mark them as being defective. So yeah, this one is popped as well. It can go here. May blow it up, see what happens. It's also important when the transistor go back in place. This one had a micro washer underneath, so the spacers need to be there to keep the transistor casing isolated from the heatsink. Well, I got these transistors back in place, soldered up. A little bit fiddly because the wires, as usual in these things, are too short. But yeah, it's all in, so I'm just going to mount the heatsinks and yeah, ready for the smoke test. Well, the moment of truth, I put everything back together, so we're just going to energize the device and just see what happens. That looks good, 13.3 volts, that looks good. Let's sit there for a while, no smoke, that's a good sign hopefully. The voltage adjust works too. A little pot meter here. Well, let's set it up for about 13.5 volts. Let's sit stationary, and then we're going to put a dummy load on there. I'm pleased. Okay, here we got this power supply. Finally had some time to fix it. I just got a 100 watt load on it, 100 watt, and it seemed to run fine. I ended up replacing 5 of these. They were all faulty. Some tested okay, but somehow with load on them they were not doing their part, so they were faulty. Replaced the whole swag of these 9014 transistors, never heard of them, but there's some NPN transistors. And then in here we got that little circuit board, the driver board, the voltage regulator. There's a pot there which you can adjust, and The Zener had died at 3.9 volts, so I put an LED with 2 other diodes in there to give me about 3.7 volts, 3.9 volts, and it seemed to work okay. It hasn't blown up yet, so as yeah, these 2 other transistors I had to replace too. They were wired up correct, or reversed, but some other reverse bias may have killed them. Still, for a design of 25 amp supply, you got a transformator in here which is 24 volts. Drop it down to 12, 13 volts, that is an enormous amount of heat, so it's a 20 amp load. Dropping 12 volts is 240 watts heat has to be dissipated in these 20, 35, 55 transistors. So yeah, it runs fine. Yeah, I may put an on-off indicator in there for 12 volts, so watch the outglow on these 2 lamps. Yeah, that's it for now, so yeah. A repair on the DF1766.